All I do is grow, grow, grow no matter what. Got growth on my mind, I could never give up. And every time I get that sinking feeling that makes me feel stuck, I just keep trying.
All right, welcome to another math lesson with Miss J. Today we're looking at connecting area models and the distributive property to partial products of the standard algorithm with renaming. So to get started, grab something to write on and something to write with. Let's go ahead and take a look at our joke of the day. All right, what was wrong with the wooden car with wooden wheels and wooden engine? Can you tell me what was wrong with the wooden car with wooden wheels and wooden engine? It wouldn't go. I thought that was so funny. Okay, I hope you got a good laugh in, and we are going to go ahead and dive into our content for today. So let's get started. All right, let's take a look at a few definitions in order to help with our thinking for today's lesson. So today we are going to utilize the area model. And if you don't remember from fourth grade, the area model is just a way for us to multiply when we break apart or decompose the number by place value. So we break it apart and then we add those two partial products or two parts of our product together to get the total product. Okay, so area model actually builds on another math term that we need to know. Let's take a look at it. The second math term that we need to know that's really important that allows the area model to work so well is called the distributive property. Now there are a lot of words on this screen, but what the distributive property means is when I decompose my number, such as in this example, when I decompose my second factor of 14, I decompose it by place value. I have 1 10 and 4 1. So I wrote that as 10 plus 4. I can break my number apart, that's what the distributive property says, and multiply by each add-in. And an add-in is just one part of our addition sentence. So if I multiply 6 times 10, and then I add 6 times 4, I could get my total product, okay? And that's what the distributive property shows us. Our last definition that we want to tackle today is, it's called the partial product. And what you'll notice from partial product, again, we're still using the concepts we know in the area model and with the distributive property, but the way that we write our answer is by adding up each partial product. And the word partial, you hear the root word part. So what that means is we're adding each part of the product. The green box, the purple box, the orange box, and the blue box are the 4 parts of this product of this number. So once we add those up, we get our total product of 782. And so our goal today is to tackle the area model, tackle the partial product, and see how those two connect to what's called the standard algorithm. And that's just a more efficient or a faster way to represent multiplication. Let's take a look. Our friends are here today. Say hello to them before we get started. All right, here's our first example. If I'm thinking about multiplying the number 21 times 5, how do you think I could decompose or break apart the number 21? Well, if I was thinking about the number 21, I can see that I have, I'm going to write it down. I'm going to use this distributive property to help my thinking. So 21 times 5. If I decompose the number 21, I notice that I have 2 10s and 1 1. So I'm going to rewrite that as 20. That's my 2 10s plus 1. And I can multiply each of those by 5. Now, when I'm able to do that, I will find my total product. So let's take a look at my model here. I grabbed my base 10 blocks to really help with my thinking. And so what you'll notice is I have groups of 5. How many groups of 5? Well, let's see. This is one group of 5 here. If I count 1, 2, 3, 4, 5. Now, if I want to represent the total area or the total product, I must have 21 groups of 5. So let me count to make sure that's what I have. You can count with me. Let's start. I have 1 group of 5, 2, keep counting, 3, 4, 5, 6, 7, 8, 9 groups of 5, I'm still counting, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 groups of 5. So I did correctly represent my multiplication sentence. Now let me use this distributive model to break my number apart. So I'm going to break it apart by showing my 2 tens or my 20 groups of 5 plus my 1. I'm going to take 1 apart, my 1 group of 5. Okay? And I just want you to see what's happening here. I'm going to draw a rectangle around my groups here, one large rectangle. Okay. And I'm going to show that I can separate them by that place value. So I'm going to separate my 1 group of 5. It's separate down here. You see that? And my 20 groups of 5. So what this shows me is I can actually rewrite this. So I'm going to take these boxes away so you can see what I'm doing, okay? You can see what I'm doing. So I'm going to slide these over here out of the way. And let's see what this model really shows us. So inside of this box, I had 20 groups of 5, correct? So across horizontally, I had 5 each, yes? And then if I look vertically, I decomposed my total area by 20 plus I had a group of 1. I decomposed my number like that. So now let's see if I just multiply those, what my total answer would be. Well, if I multiply 20 times 5 or 2 tens times 5, I know that 2 times 5 is 10. I have 1 power of 10, so that gives me 100 here. Then I'm going to multiply by 1 times 5. 1 times 5 gives me 5. So if I add up my 100 plus my 5, I would see that my total area or the total number of base 10 blocks I have would be 100 plus 5. That gives me 105, okay? And actually, this is much easier for me to do than to try to mentally multiply 21 times 5. So we're going to step our example up here just a second to see if we can apply this to a 2-digit by 2-digit number. So let me go ahead and move this out of the way quickly. And let's get our next example here. So here's our next example. Let me adjust my camera so you can see it. Here's our next example. It is coming up on the camera. Let me make sure. There we go. Now let's take a look at our next example. So in this case, again, we're going to do all 3 steps. I want you to try to see how they connect. I want you to try to see how they connect, okay? So I have the area model. I have 34 times 22, okay? So the first thing I'm going to do is I noticed in this example of my area model, I notice that I have 34 as my first factor, okay? And because 34 is my first factor, I'm going to decompose that here horizontally at the top of my area model. So 34, that's 3 tens. I can write that in standard form as 30 plus I have 4 ones, okay? So I've decomposed my first factor. Now let's go ahead and move on to the second factor. The second factor I have is 22. So I'm going to decompose my next factor. I have 2 tens. I can represent that in standard form by writing the number 20 plus 2 ones. So I have 2 tens plus 2 ones. Now, what I'm going to do is I'm going to multiply. I need to multiply these numbers, okay? So let's think about that. I've broken apart my numbers. Now I'm going to multiply the value of this 20, this 2 tens, by each part of my number 34. So let's do the first factor. Let's multiply the first number. So let me make a quick adjustment. Okay. Now let's go ahead and multiply. I know that 20 times 30, or 2 tens times 3 tens, is the same thing as 2 times 3, which is 6, plus 2 powers of 10 should give me 600, okay? It should easily give me 600. Let's multiply our next factor. I'm going to take my 20 and then I'm going to multiply it by 4 ones. Well, 20 times 4 ones is the same thing. We've been learning about powers of 10 and patterns in our place value chart. 2 times 4 is 8. Those are my basic facts, okay? My basic facts that I remember. And then 2 times 4 is 8, plus 1 power of 10 should give me 80. And that 80 should go right here, okay? Inside of this box. Now you'll notice that the size of my boxes are different sizes because the value of the numbers I'm multiplying are different. The value of my 600 is much bigger than the value of 80, and you can see that that box is much larger. Now that I've multiplied 20, or 2 tens, times each part of my first factor, I'm going to multiply my 2 ones by each part of my factor. So I have 2 ones times 3 tens, or 2 times 30. That's the same thing as 2 times 3, which gives me 6, and I have 1 power of 10. That's going to give me 60, okay? So lastly, I'm going to multiply 2 ones times 4 ones, and most of you quickly figured it out. That's going to give me 8 ones. So if you look at my model here, you can see that all of my partial products that were related to the hundreds place are in blue. All the partial products that were related to the tens place are in purple, and then all the partial products related to the ones place are in yellow. Now, in order to find my total product, what I would do is I would add up all of my parts. So I'm going to look horizontally because that's easy for me. I'm going to look at 600 plus 80, that's 680, plus I have 60 plus 8, that's 68. And if I add those two together, I have 8 ones plus 0 ones gives me 8 ones. 6 tens plus 8 tens gives me 14 tens. And if we remember from our place value chart, anytime I have more than 10 in any place value, I have to bundle and regroup. So I'm going to take those 10 of those tens and rename them as 100. And I'm going to show that by putting my 1 down here. I know that some scholars are used to putting it up here. I like to put it down here so I don't get confused about what I'm multiplying at the top. But it is okay if you decide to rebundle up here, okay, above your 6 in the hundreds place. So again, I have 8 ones plus 4, 8 ones plus 8 tens, excuse me scholars, 8 tens plus 6 tens gives me 14 tens. I bundle 10 of those, change them into 100. I have 4 tens left over. That's how I get the 1 and the 4 for 14. Lastly, I'm going to add my hundreds. I have 600s plus 100. That gives me 700. So my total should be 748. Let's now look at how the partial products would relate, okay? So I'm going to do the same thing. I will always begin with I want you to notice that vertically when I lined up my partial products, my first factor was 34, so at the top I put 34. It just helps me to easily compare my partial products if I line them up the same way, okay? So because my first factor is 34, I put 34 at the top, and then my second factor is 22. So I'm thinking just about the area model and how I decompose this. So what I'm really doing is I'm going to break this apart. I'm going to take my 2 ones and I'm going to multiply it by 4 ones, and then I'm going to multiply it by 3 tens. So let's do that. Here we go. 2 times 4 ones, because this is a 4 in the ones place, just gives me 8. Now I'm going to add my next partial product. Again, I'm multiplying my 2 by every part of my factor at the top. So 2 times 3 tens, or 2 times 30, should give me 60. Now that I've multiplied by all of my factors, now that I've multiplied by all parts of that first factor, I'm going to look at now multiplying this 2 in the tens place times each part of the factor. So I have 2 tens, or 20 times 4. 2 tens, or 20 times 4, is going to give me 80. Okay? 2 tens times 4, 20 times 4 gives me 80. And lastly, I have 2 tens times 3 tens, or 20 times 30, should give me 600. So you can see I have all 4 parts of my partial product, and to get my final product, I need to add those together. You might notice some similarities between the area model and the partial products. So let's add these up. 8 ones plus 0 ones gives us 8 ones. 6 tens plus 8 tens gives us 14 tens. I'm going to bundle 10 of those tens to the hundreds place, change it into 100, and I have 4 tens remaining. Lastly, I'm going to add 6 hundreds plus 100. That gives me 7 hundreds. So far, my product is the same, okay? I have 748 here, I have 748 here. The last connection we want to make is we want to make a connection to the standard algorithm. How do all of these relate? So you'll notice in the standard algorithm, what I'm doing again is I begin with that 2 in the ones place, and I'm going to multiply, just like if I were to break it apart in the area model. I'm going to multiply my 2 ones by 4 ones, and then I'm going to multiply my 2 ones by 3 tens. So let's go ahead and take a look. The standard algorithm is just a little bit more efficient, and you'll see what I mean just a second. So if I multiply 2 ones times 4 ones, I get 8 ones. So I would actually represent that by writing an 8 there, or putting an 8 there. Now, if I continue, I'm going to multiply 2 ones, or 2 times 3 tens. That's really 60, okay? That's really 60, okay? So what I would do is I would indeed, because I have more than 10 tens, I would bundle and regroup. Actually, I apologize, scholars. Because I have 2 times 3 tens, 2 times 30, just gives me 60. So I would actually put my 6 here to show 6 tens. See, the 6 in the tens place shows me that I have 6 tens. So now I've multiplied by my 4 ones, I multiplied by my 3 tens. So I've multiplied by every part of that top factor. So I'm going to now move on and multiply this digit, the 2 tens, by every part of my factor, every place value of my factor here at the top. So let's take a look. The first thing I'm going to notice is I have 2 tens, or 20 times 4. 20 times 4, that's going to give me 8 tens. That's less than 10. So I'm going to go ahead and put an 8 in the tens place and a 0 in the ones place. That's how I write that in standard form. I will put an 8 here, okay? Now, the next thing I'm going to do is I'm going to multiply 2 tens times 3 tens. That's really like 20 times 30. 20 times 30 is 20 times 30 is 6 hundredths, or, excuse me, 20 times 30 is 60 hundredths, or, wait, let me think about that. Did I say that correctly? Let me think. 20 times 30, 3 times 2 is 6. I have 2 powers of 10, so that's 600, okay? So I'm going to have a 6 in the hundreds place, okay? So I would bundle 60 of those tens and to make them into 600s. That's where I get a 6 in the hundreds place. So now what I'm going to do is add up. You see, scholars, teachers make mistakes. I'm trying to make sure I use the correct language for you all. So let's see. Now you'll notice when I add my standard algorithm partial products up, I have one row here and another row here. Okay, this top one represents what I multiplied by the ones in this bottom digit. The next one shows what I multiplied by the tens. Okay, so let's add them up. 8 ones plus 0 ones gives me 8. 6 tens plus 8 tens gives me 14 tens. Again, I must bundle 10 of those, change that into 100, and I have 4 tens remaining. Then I have 6 tens plus 1 10, it gives me 748. So while we were able to accomplish the same product for all 3 examples, you'll see the area model lets us break those numbers apart, okay? and then we can add we can add up all the parts together. The partial products lets us show how each part is multiplied, and we add them all together. The standard algorithm really just combines our partial products in a little more efficient way. So we're writing a little less, but then we add those together. So let's see, we have one more example. Let's see if we can make all of this, well, let's see if we can practice with another example is what I mean to say. So let me try one more example here. Okay, so in our next example, let me switch this out. We do have another 2-digit by 2-digit number. This time we're multiplying 64 times 73. So this time, my hope is that we are going to simply, excuse me, scholars, my hope is that we're simply going to walk through each part of the process and be able to multiply those numbers, okay? So let's go ahead and give it a try. Let's go ahead and give it a try. Just a second, scholars. Okay, we're gonna go ahead and give it a try. Here we go. All right, so if I look at my next example, let me switch my camera. Here we go. I'm ready to roll. We're going to work through this together. And let's see if we can, again, see the similarities in the three parts. The first thing you'll notice is I have 64 times 73. So what that tells me is I have two 2-digit numbers that I need to first decompose in order to do this area model. Remember, decompose means break apart. So let's break these numbers apart. I'm going to go ahead and draw an area model. You can draw with me to practice. Okay. So I'm going to begin by drawing a rectangle. Okay. And now in my rectangle, I am going to have 64 as my first factor. I'll put that at the top. I have 6 tens. I represent that by 60 plus 4 ones. And I'm going to draw one horizontal line to show my partition and breaking apart those two numbers, okay? Now I have 73, okay? So I'm going to show, I think I'm going to write, I have 70 or 7 tens down here, and I want to write that I have plus 3 ones up here, okay? So we're going to now go ahead and multiply these, all right? So let's go ahead and do it. Let's knock it out. The first thing I'm going to multiply are my 3 ones. This is my 3 ones times every part of my first factor. So first I have 3 times 60, that's 18. 3 times 6 is 18. Those are my basic facts. Plus 1 power of 10, that's 0, okay? Then I know that I have 3 times 4, and those are just basic facts. I know that to be 12, okay? Now, let me go ahead and multiply my next partial products by the second part of my number. So I'm going to multiply my 7 tens times 6 tens, or 70 times 60. Well, my basic facts here, again, skill we learned just last week, 7 times 6 is 42. 42 is the first part of our numbers. I see I have 2 powers of 10 in my 2 factors, so that means that's being multiplied by 100. So my answer, 70 times 60, would be 4,200. Now, I have one more thing to multiply. I have to multiply 70 times 4. Okay, that's the second part of my number. 70 times 4, well, my basic facts are 7 times 4. 7 times 4 is 28. 28, so I'll write that first. And then I have 1 power of 10, so that's 280. Now, to show my total product, I need to add up all of my partial products. So I'm going to add 180 plus 12. That's going to give me, I know that's going to give me 192. Plus I need to add 4,200 plus 280. That's going to give me 4,480. So if I add these two up, I should get my total product. So let's take a look and see what that is. 2 ones plus 0 ones gives me 2 ones. 8 ones plus 8 tens plus 9 tens gives me 17 tens. I'm going to bundle one of those to the next place value. I have 7 tens remaining. 4 hundreds plus 5 100 plus another 100 gives me 6 hundreds. And then I have 4 in the thousands place plus 0 thousands gives me 4,672. So now I'm going to do the same thing and relate it to the partial product. Let's go. We're almost there, scholars. You're doing great. Now let's take a look. The first thing I'm going to do is I'm going to circle my 3 in the ones place because I have to remind myself that I'm multiplying every number in my top factor by 3 ones. So let's go ahead and do that. 3 ones times 4, or 3 times 4, is 12. So my first, I'm put a 1 in the tens place, a 2 in the ones place. My second part of this product would be 3 ones times 6 10, or 3 times 60. 3 times 60, we know that to be 180. Okay. Now I've multiplied by every part of that first factor. I'm now going to look at the second part and multiply my 7 tens by every part of my top factor here, by every part of the 64. The first thing I'm going to have to multiply is 7 tens. This is 7 in the tens place, so that's 70 times 4. 70 times 4 is 280. Now I have 7 tens times 6 tens. 70 times 60 will give me 4,200. Okay. Now that I have all of my partial products, I want you to notice how this is lined up here. Okay. Because I have 2 digits in my top number, I should have 2 partial products. You'll see 2 partial products in green for the numbers I multiplied by 3 ones. Because I have 2 digits, a 6 and a 4, in my top product, I should have 2 numbers that I multiplied by 7 tens, and I do. They're in pink, okay? Now that I know that I have the correct number of partial products, I should go ahead and add. And let's do that. I have 2 ones plus 0 ones gives me 2 ones. I have 1 10 plus 8 tens, that's 9 tens. 9 tens plus 8 tens gives me 17 tens. I'm going to bundle one of those. I'm going to bundle 10 of those tens and change it into 100, and I have 7 tens remaining. Now let me add up all of my hundreds. I have 1 plus 2 plus 2 plus 1. That gives me 6 hundreds, and then I have 4 thousands remaining. So I can see that my products do match. My total products match. Last step, we got to relate this to the standard algorithm. Again, I'm going to always start with my ones place. I'm circling the ones, and let's multiply. First thing I'll do is I'm going to multiply 3 ones times 4 ones. So in the standard algorithm, it's more efficient, or it's a faster process because we combine what we know about our place value chart and bundling and regrouping. And let me show you what I mean. 3 ones times 4 ones gives me 12 ones. I'm going to bundle one of those. I'm going to bundle one of those over here to the tens place. I put my 1 here, and then I'm going to write down my 2 ones that are remaining. Now I'm going to keep multiplying. I have 3 ones times 6. 3 times 6 tens gives me 18 tens. Plus this 1 10 that I bundled, that will give me 19 tens. Well, because I have 19 tens, I have to take 10 of those. I'm going to bundle those to the next place value, to the hundreds place, and then I'm going to write the 9 tens that I have remaining. I'm going to go ahead and cross out this 1 10 that I bundled there so I don't get confused later, okay? So now I have, and then I had a 1 in the hundreds place remaining, so I'm going to put that 1 there, okay? So now my next step is to multiply all of my tens, okay? My 7 tens by every part of this top factor. So again, I'm going to start by multiplying 7 tens by 4 ones. Well, 7 tens times 4 ones, 7 times 4 is 28. So that's 28 tens, okay? 28 tens. And because I have more than 10, I'm going to bundle 20 of those tens, and I'm going to regroup them and call them 200. So I'm going to put a little 2 right here to show that I have regrouped them. And then I will have 28 tens, so that means I will have 8 tens and 0 ones remaining. 7 tens times 4 ones gives me 280. 280. Now, the next step, again, scholars, if you're more comfortable bundling up here, that's fine. I'll do another video showing bundling above the numbers. But for now, let's try and see if we can tackle bundling down below. So I've multiplied my 7 tens by 4 ones. 7 times 4 gives me 28 tens. I bundled 20 of those tens over to the hundreds place. I get 2 tens, and then I have 8 tens remaining. So I could write that in standard form as 280. My last step here is to multiply 7 tens times 6 tens. So I have to think about, I also bundled 2 tens there. So 7 tens times 6 tens gives me 42 tens plus 2 more. That's 44 tens. So I'm going to take 40 of those tens and bundle them over to the thousands place. Put them over here. Then I have 4 tens remaining. So that will give me 4,480. Now to finish up, I'm going to go ahead and add these together. 2 ones plus 0 ones gives me 2 ones. 9 tens plus 8 tens gives me 17 tens. I bundled my 1 10 over here to the hundreds. Now I have 100 plus 400 plus 100 gives me 600s, and 4,000s plus 0 thousands gives me 4,000s. So again, you can see that if we're looking at that standard algorithm, once we get those steps down, it's actually a much faster process. I actually wrote a lot less for the standard algorithm, but the goal, our goal is to understand why the standard algorithm works the way it does. And it works the way it does because of the area model, using the partial products. Essentially, it works the way it does because of that distributive model, okay, distributive property. So scholars, there are many parts to this video. I want you to play, pause, stop, practice. I want you to practice this skill because once we understand it, you can multiply really any number, okay? 3-digit by 3-digit, 4-digit by 4-digit. It's all the same, but we have to understand why. Okay, so I want to thank you for joining me for another math lesson. And scholars, I will see you next time on our next math video.